This problem here is actually it's actually a pretty simple problem once you get the gist of it. It's usually the case here is it's your first time in being introduced to using some type of a theorem to solve a problem. So when you're in a calculus course at this level, or any math course at this level, you're now going to need to reference theorems. So it's very important that you read the book, because when you take the exam, they're going to ask you like word for word what theorems are. So they may not even give you a computational problem like they do in this question on a test. They might just ask you specifically, if f is this on this, what is this? And if f is this, what is this? So you got to read the book. You got to memorize these things. Otherwise, you're not going to be able to answer these questions on the test. When you get to calculus, you can't skate by without going through the book. You could in the previous courses, but calculus going forward, if you're not reading the book and reading each section prior to the section that the lecture's on, you're going to be in trouble. You need to read it. If it's section 3 on Tuesday at noon, you need to make sure you read that section prior to the lecture at this point at the college level. Okay, but really this problem is quite simple. You just follow the rules that were given to you in the book. This is from the Stewart Calculus book. And so you look at the first thing, f is continuous on the closed interval. So our function f is x minus 4 divided by x, and our interval is 2 divided by 4. So you can't just go yes, yes, and then do this part. That would be wrong. You need to show it. So the first thing you need to do is find the domain of f. And the domain of f, as you can see here, it's clearly all real numbers except for x cannot be equal to 0. So the domain will be negative infinity, 0, union, 0 to infinity. And you can see that 2, 4 is in 0 to infinity. So this is just saying that these numbers lie inside this boundary. So case 1 here is true. And then we'll do part 2. We need the derivative. So f prime, I'm hoping you're okay with derivatives. I'm just going to write it out here, is going to be 1 plus 4 over x squared. And then the domain of this is actually going to be the same domain as this here. And so if you hopefully remember derivatives, the derivative of x is 1, and then we bring this this is negative 4x, the negative 1, the negative 1 comes down, becomes positive, and then negative 2. So just in case. And we can see again the domain D is equal to, again, 0 to infinity, union, negative infinity to 0, negative infinity to 0, union, 0 to infinity. And again, we make the statement AB, in our case 2, 4, is in that domain. It's in D here. This is D. We can see that this lies in here. A situation that this would fail or something is if we take the derivative, we check the domain of this, and this this open interval might not work with it or something. So you might have a question on the test where the domain's not even there. So you just instantly go, the domain, it's not in the domain, so you're done. You don't need to do anything. And they'll trick you like that too. A lot of times these questions pop up on the test because they want to see if you're paying attention. They're not going to just ask you to do the computation like you are in this problem. They're going to ask you specifically, they're going to give you a trick question. For example, if the domain was 0 to 4, then it would fail, because 0 is not in this domain here. So you got to be careful. You got to pay attention. That's why you got to read the theorems. But anyways, going forward, so this one here is true as well. So now once that's true, then you follow this formula here, and just pay attention. This is the derivative, and then this is the original function, and then b and a are 2 and 4. So you take the derivative with a c in front of it. So part 3, you go 1 plus 4 divided by c squared is equal to f of 4, which is 4 minus 4 over 4. So that's f of 4. And then minus f of 2, which is 2 minus 4 over 2. And then we divide that by 4 minus 2. And then we solve for c. So then from here, it's just arithmetic. And let's see here. So this is going to be 4 minus 1. And so we're going to have 4 over c squared is equal to 4 minus 1. And then this is 2 minus 2, which is 0. So minus 0. And make sure you're keeping with your parentheses over 2. And then I brought the 1 over. And so then that's equal to 3 halves. And then that tells us then that c squared is equal to, well, that's going to be, I can bring the 4 down here and I'll get an 8. And so c squared will be equal to 8/3, which then tells me that c is equal to plus or minus the square root of 8/3, which is plus or minus the square root of 8 is, that's 2 cubed, so 2 can come out, and so we'll have 2 root 2, 3, like so. And so 2 multiplied by some fraction square rooted, is this, which one of these, because we have 2 answers, plus or minus, but which one of those actually are in the domain, right? So negative 2 root 2/3 is not, and this symbol, it's called in, it's not epsilon, it's like it looks just like this here. It's called in, it just means it's in the domain if you're not familiar with that. Anytime you see a symbol you're not familiar with, look it up. It's usually not that difficult of a thing. Look it up, figure it out. Anytime you see a word that you're not familiar with, look it up, figure it out, because putting it off is not going to help you. Same with any course, any English, anything. So this is not in the domain, so it doesn't count. But so then finalize, I'll finalize it here. So final, just do a box here. Okay, so this symbol means therefore, and we know that 2 root 2, 3 is in 2, 4. Therefore, c is equal to 2 root 2/3. And that is the answer right there. So that they're asking, then there is a number c in AB such that this is true, and we have found that using the mean value theorem. So that's the gist of it. It's not that difficult, but I didn't want to do the entire problem for you, but I wanted to explain that the reason I did the whole problem from start to finish is because it's not likely that this type of question will show up on the exam exactly like this. I would say it's a 50-50 chance maybe, so it's 50% likely. But usually from my experience, what I see is they have you do a fill in the blank and then do this, or they give you a question that fails. So pay attention when you're doing that, and let me know if you have any questions. Thanks. Close this thing out here.